out commercially. So this started as a traffic analysis, a traffic identification project, focusing more on peer-to-peer encrypted data. But in the process, actually evolved into a more security-oriented blockchain type of effort. So the background to this is that we know that IT managers do have trouble enforcing use policies, whether you're talking about the enterprise or a campus network or something that academic network has. And part of the problem, or large part of the problem, is because large part of this traffic is actually unaccountable. Some estimates say that 30% of the traffic is unaccountable, and it's also estimated that 70% of the traffic is actually unwanted. And all this, of course, also translates to dollar values for those people who care. What's interesting here is that more than 90% of these networks actually do have a firewall or a traffic shaper or some kind of control device in place. And because the problem is rooted in the fact that traffic is unidentifiable, IT managers have a very tough choice. So the one choice is you either block everything that you cannot recognize, in which case you get employees complaining, so-called collateral damage, or you actually let all the unidentified traffic through, in which case you have risk of data leaks, policy violations, etc. Now, if you look at the technical problem, the root of the problem, if you really want to have decent security, what you need to win 100% traffic identification. So compare that, for example, to the financial sector, where an accountant comes in, they want everything to actually add up. In our networks, we don't really have this capability yet. So anything less than 100% would result in either less security or too much security. Now, you probably have seen many of the products, so-called API products, traffic shaping products. And these products actually only focus on the top 10, top 20, top 30 applications. Just enough to control the traffic, to reduce the pressure on already clogged links. Would it be possible? So the question is it possible to actually get that 100%? To detect not just the top, the most popular applications, but also those that may have only 0.1% of the traffic, but might be the most dangerous one. Thinking what the scheme is thinking. Okay, so just one example of a product that's actually quite highly used. So what we did is we actually installed it and we launched a BitTorrent client, enabling the encrypted transport for BitTorrent. What you can see, you probably cannot see, is that what the corner is that actually only recognizes 10% of it. So that's just an indication of the state of affairs in the industry. So to actually address this, you need many different things. So the basic idea is to actually get from statistical reporting to kind of the market gene graph that we all like, and permitted policies that actually specify specifically which things you want to block because you know they're bad. To actually get to restrictive policies, to actually get to the point of saying we block everything because those things we explicitly know and we know what they are and actually approved to be good or approved to be neutral. So in this project, we've actually built a box and we actually wrote a traffic analysis engine that can get fairly close to that goal. The basic idea is that you do have a flexible architecture. Everything is done in software, and what being software can still do multiple gigabits on a commodity or original hardware. We actually went one step further when it comes to traffic identification. We're looking at thousands of applications rather than just a few hundred. And we also have the capability of automatically recognizing a large percentage of new protocols that actually come on the line. So that involves some computer science here, some machine learning. And based on that, we're looking at traditional applications such as statistics, type infinity. We're looking at policies, and we're also looking at daily jobs. I just benchmark. So this is on the all the way to the right is the number of applications that we can detect. These are typical numbers of companies in the industry. So we have actually been working on this for 2 years now. We have this deployed on many sites. Quite interestingly, large percentage of those sites are actually either campus networks or academic, networks. And the reason is that those people are actually interested in this technology because they do actually suffer from security. So while they do want to actually keep the networks open because it's an academic environment, they want to support innovation, new applications, they want to allow people to experiment, they don't want to completely lose control. Okay, so this is the kind of performance that we do see in some of the sites. It's actually pretty close to 100%, except for one site, the second one, which happens to have a lot of proprietary VPN traffic going in the background. So actually it took us quite a while to recognize it and actually determine that it's not some kind of malicious site, but it was some kind of proprietary wireless punishing thing that they were not even aware about. We have also other sites, it's not just higher education, so some government R&D, some ISPs, that we're working with. And just to connect back to the original question, is this just a matter of controlling people here, or is there more to that? So here's a list of findings from one of the networks that we put our focus on. So this is just as an indication, this is the R&D organization with about 650 employees. They do have everything in place. They have a traffic shaper, there's a firewall, there's IPS, so they told us, what else would you find on our networks are clean. These are the kind of things we found. So for this particular organization, having remote control video cameras, streaming video out of the building is okay. In some other organizations, it might actually be a no-no. Although this is a firewall environment, there were people actually running their PNC servers from the inside. Although it's an IT company, it's an IT R&D environment, people were actually trading products, doing working hours. And the more security-related stuff is that we actually found 4 botnets inside the organization that nobody was aware of. Some of them we actually identified because the hosts were actually sending large numbers of outgoing emails, which happens to be spam. And of course, this organization does have this anti-spam solution, but it's only looking at ASOS traffic. They never really look at the outbound. And the result is that this organization was actually blocked for about by the anti-spam numbers. And of course, you have the usual, peer-to-peer and YouTube and all of this in terms of the traffic volume. But all this is actually pale compared to the other kinds of policy violations, security incidents that this same technology actually figures out. Okay, now if you want to see specific examples, I don't know if I will use a little dense on this. So these are specific examples that we collected using